What is the average kinetic energy of the molecules contained in a body? Answer is temperature. Completed? Okay.
No, sir.
Upper also not done?
Next.
Question number 2. Which of the following is equivalent to 1 calorie heat? Which of the following is equivalent to 1 calorie heat? What is the answer? Do you know? 1 calorie joule heat means 4.2 joule. Completed. Question number 3. Which of the following is the refractive index of water? What is it? Which of the following has the highest refractive index? Right now. Okay. Which question is just you can modify the question. Which of the following has the highest refractive index? Sometimes it happens. The question also like that. Which of the following has the highest refractive index? What is the answer? Diamond. Diamond has highest 2.42. Hey, it's completed. Now we'll go to question number 4. These are all MCQ. Which of the light? Which color of the light? What a question is making this Luniba? Which color of the light has the highest speed in a medium? Which one? Red. Red has highest speed. Eh? Okay, now B asks you. So define dispersion of light. Can you define? And sometimes question can be asked. Draw the diagram to show dispersion of light. Write down that. Show the diagram to show. No, no, show. Draw the diagram. Draw the diagram to show refraction of dispersion of light. It became too much bright. I think our children are going to use spectacle very soon. Hey Baba, oh, what is this? Bale Maila. This is the way. Why to make too much bright? Don't have the habit to look at bright light. Question number 2. Why does light bend when it passes from one medium to another? There is change in speed of light. What is there? Change in speed of light. So main thing is that how to write answer, you just think and do accordingly. What is 1 calorie heat? Do you know the definition? 1 calorie heat, you find out.
To increase the 1 degree Celsius of any.
You look at the book and tell. Look at the book and tell.
Yes.
Then you can say correctly. Did you find? The amount of heat required to raise the temperature of 1 gram pure water by 1 degree centigrade. Check in the book. And which of the cup is open here? The two cup is open. So later I will check the cup here. So number 4, define specific heat capacity. Can you define this specific heat capacity? The amount of heat required to raise the temperature of
Unit mass and 1
unit mass of a substance by 1 degree centigrade.
Okay.
Remember this thing also. So heat and light only from 2 chapters they are made.
Yeah.
They are made from only 2 chapters. Yeah. Okay. What is NMLS expansion of water? Do you know? Define critical angle. What is the critical angle of a diamond? We enlist any 4 events that are caused due to refraction of light. How much heat is supplied to raise the temperature of 100 gram of water from 5 degree to 9 degree centigrade? Here we have to remember it's given in gram.
Yes.
You have to change into kg. How to convert?
0.1 kg.
Yeah, 0.1 kg means 100 by 1000.
Yes.
And difference in temperature dt is how much?
Kg
90 minus 5 means
85.
85 degree. And specific heat capacity of water is not given.
4200.
So, what is specific capacity of water? 4200 joule per kg per degree centigrade. Which formula is suitable here? Where champion students are there. Now I'm not going to talk more. Okay. So children, now we will start our next topic. And this period also, next period also will forward. Okay. So for some days, we will just forward our lessons. It became a bit slow. And when this is the time of His presentation is there? Oh, okay. This one, okay, come here. Okay, Saurat's presentation is there. Saurat, Z's presentation. Saurat. This one? Or Simres? Or Simres and Saurat. Okay. So everybody please pay attention. Simres Maharjan for his presentation. Now, open your mind. Open your mind. Attention. Make back with spirit.
My presentation is about real image and virtual image. During formation of an image by a lens or a mirror, the reflected or reflected ray may or may not intersect each other really. If an image is formed by the actual intersection of the reflected ray, it is called a real image. The real image can be obtained on a screen. A convex lens and a concave mirror can form a real image. The image which is formed by the apparent intersection of the reflected or reflected ray is called a virtual image. Such images cannot be obtained on a screen. A concave lens, plane mirror and a convex mirror always forms a virtual image. So next is difference between the real image and virtual image. Real image, it is formed at the point where the reflected rays meet. Virtual image is formed at the point where the reflected ray appears to meet. Real image is always inverted and virtual image is always erect. Real image can be obtained on a screen and virtual image cannot be obtained on a screen. So our next topic is laws of reflection of lens. The position and nature of image formed by a lens can be obtained either from a ray diagram or by calculation. The following laws should be understood well for the construction of ray diagrams in both concave and convex lenses. It is because constructing the ray diagram of image formed by a lens, any two of the following rules must be followed for the correct location and position of the image. So the first rule is an incident ray of light passing parallel to the principal axis refracts through the principal focus. So second law is an incident ray passing through the optical center emerges without deviation after refraction in both convex and concave lens. And third one is an incident ray passing through the principal focus in convex lens refracts parallel to the principal axis after refraction. In the case of a concave lens, if the incident ray appears to pass through the focus, it refracts parallel to the principal axis. And next topic is ray diagram and properties of image formed by a lens. In the given figure, F is the principal focus of convex lens and O is its optical center. The distance OF represents the focal length. The point 2F on the principal axis is radius of curvature. If F is equal to 3 cm, the point 2F is at a distance of 6 centimeter from O. BP and BO are two incident rays drawn from the same points B of the following of the object. AB, which is kept beyond 2F of the convex lens, the ray BP is parallel to the principal axis. After refraction at P, it passes through F along PV. The rays BO passing through O emerges without deviation along the OB. Meet at B. When Hence, AV is the real and inverted image of AV. The image A and B lies in between F and 2F. The distance between the object and the optical center O is called object distance. The distance between the image and optical center is called image distance. Okay.
Okay, thank you very much. All right. When there is some gap, then it is quite difficult to show the link, right? So we have started our topic. Lens. How many type of lens are there? There are two type of lenses. What are they? One is convex lens. This is convex lens. This is concave lens. Convex, its central part is thick and edges are thin. Side it is thin, central part is thick. Okay. So Friday, I think some students presentation is there in lab. At that time, if you remind me, sir, could you show me the convex lens and concave lens? I'll show you. Understand? And this is concave lens. In concave lens, middle part is thin, edges are thick. That is the thing. Okay. So in this class, how many children are using spectacle? Only two, the one boy and one two girls and one boy, Bibeki and this. So these children, they have got one problem in eye. That problem in eye will be discussed later on. Mainly there are two type of problems. One is the problem in which they cannot see far away object. Another is the problem in which they cannot see near object. So these children, they cannot see far away objects. They can see near objects. So that is called short sightedness. What do you call it? Short sightedness. And all of them are using a concave lens. Which lens is lens? So when you just look at some paragraphs through that spectacle, you can see a smaller one. Have you noticed or not? You just check it. It seems smaller in comparison to this one. But some old people, aged people, what do they use? A lens. So means spectacle with lens. That is convex lens. They can see far. They can see far away objects clearly, but they cannot see near away object. And when we ask them to read something, they'll keep on far away. And children, what do they do? Like that. Normal people, they can keep anywhere else, isn't it? So two type of lenses. Convex lens is called converging lens. What is the spelling of converging? Converging. Why is convex lens called converging lens? Because when a parallel beam of light is incident on a convex lens, the lens converges into a point after the refraction. You can see here, these parallel rays are passing from it, and after refraction, are they meeting at one point or not? All of them are meeting. That's why it is called converging lens. They meet at a point after refraction. After refraction. See, are they bending or not? Are these rays bending? And the concave lens is called diverging lens. What do you call it? Diverging. What is the spelling? Diverging. Why? When the ray of light strike with the lens, they do not meet. They scatter. They scatter from a point. They diverge. They diverge. That's why diverging lens. Okay. Here is differences between convex lens and concave lens. A minimum two differences you have to remember. Which one you feel easier? Remember that one. Because we know four type of questions are asked in science, right? Multiple choice questions, very short questions, and long questions. So this differences between it will not be asked of 4 marks. Maximum it will be asked of 2 marks, either 1 mark or 2 marks. That's why if you become specific and read or write, that is better, right? So two type of lenses. What are they? Convex lens and concave lens. So what is the first difference? Thicker at the middle, thinner at the middle. Converges the parallel beam of light, diverges the parallel beam of light. Third point, can you see what is given third point? Focus is real, focus is virtual. Okay, what is that real, what is virtual? Please you see here, student. In case of this convex lens, are all the rays of light meeting or not? They are directly meeting. That's why one point is here, right? So such type of point is real focus. What do you call it? Real. They are meeting at a real point, no? At a fixed point. But in case of concave lens, this point, it is not real, it is imaginary, virtual. It seems we may guess they may be scattering from here. That's why real focus, virtual focus. Real focus, all they meet together. Virtual focus, they appear to meet together. Okay, appear to meet together. That's why, look at here. Here is a line. Is a line or not? But here is not a line. This is dotted line. Is here. Is a dotted or not? Imaginary. So some terms related to lens we need to remember. What is the first term? Optical center. Is it written at O? O. These are the optical centers. Let me make a bit bigger this slide. So what is optical center? The geometrical center of a lens is called the optical center. When there is a diagram or the real object, they say lens, it is especially spherical in shape or circular in shape, and its center point is called optical center, right? So if I draw like this, O. So is it optical center? Is it optical center? I wrote there O, but in reality that is not optical center. It must be at the center of the part, that one, isn't it? I think it may lie here. What is this? O, but this is wrong. Remember, geometrical center. Okay. What is second one? Center of curvature. Actually, it is believed that lenses are made from two imaginary spheres. Two imaginary spheres. So, first imaginary sphere center is called C1. Second imaginary sphere center is called C2. So, these centers are called center of curvature. So, see here, these two spheres are overlap, and what is formed? It's just like disjoint set or overlapping set. Overlapping, they are overlap. And over here, disjoint. And here also there are two imaginary spheres. This is C1, and what is this? C2. What are those points called? What are those centers called? Center of curvature. Radius of curvature. What is radius of curvature? Distance between the optical center and center of curvature. See, now children, look at here. Here is optical center. What is this distance called? Radius of curvature. What is this distance called? Radius of curvature. Got the point? Yes. What is next one? Principal axis. What is principal axis? How many center of curvatures are here? 1, 2, 2. The line that passes through the center of curvature is called principal axis. So, this line is passing through C1 to C2 or not? It can go further away also. From here also. Center of curvatures. Got the idea? Next one, student. Principal focus. What is next point? Principal focus. Children, look at here. Here are two parallel rays of light. Please pay attention here. Eh? One parallel light, ray of light here, another ray of light here. After refraction, they are meeting at a point or not? Are they meeting here? But here, are they meeting? They are appear to meet. So, such type of points where refracted ray meet actually or appear to meet, that is called principal focus. How do you define? By using the word F. Suppose, why actually in light you have to draw many diagrams. So, this is a lens. What is this? What is this line? The line that passing through, this is called principal axis, right children? And if I write here F, here also it must be written F. We have to write F in both sides, hey, remember. And double of F, what is it called? 2F. Double of F is called 2F. And later on you have to draw the diagrams as well. And you must not forget to mark it as minimum how much centimeter? O to F, it should be 2 centimeter. Or F to 2F, how much? The value should be equal, I mean. Understood or not? So don't make haphazardly. First of all, you mark O. From O, you just measure 2 centimeter and keep there or place there F, F to another 2F. And this side also F, we have how much centimeter here? Here also. It will be easy, no? Sometimes what do? They make O to F 2 centimeter, F to 2F 1 centimeter. Is that right or wrong? 2F means double of F is there. Hey. And now I think next point is there. Principal, no, focal length. What is the next? So this is principal focus, F. F, distance between OF, that is called focal length. Distance between optical center and principal focus, that is called focal length. It is denoted by F, small f, denoted by small f. And one thing you have to keep in mind, there are two types of lenses, right? What are they? Convex lens and concave lens. In case of convex lens, focal length is positive. Focal length is positive. In case of concave lens, focal length is negative, because there is imaginary focal principal focus, right? What I said you? Focal length of convex lens is positive. Focal length of concave lens is negative. If so, the power of the lenses which these both children are using is also negative. If focal length negative, power also will be negative. One formula is there. The formula is, what is the formula to calculate power of lens? That is P equals to 1 by F. What formula is there? P equals to 1 by F. Okay, this thing remember. Here is one minor experiment. It is said to measure the focal length of a lens. So, what is kept here? You know, here is lens, here is object. Where the image is formed? The image is formed in the screen or not? When we measure the distance between the image and lens, we'll get focal length, right? Now the matter has come. Real image and virtual image. Real image and virtual image. So children, if the rays are parallel, they meet at a point, an image can be formed here. So if the image is formed by actual intersection, that is called real image. If apparent intersection, what is it called? Virtual. I mean, so are they meeting together or not? So this is actual intersection or apparent one? Is it actual or apparent? Actual. Is it actual or apparent? Are they meeting together at all? They are not. So see, whenever there is straight line, that means they are meeting actually. But if there is dotted line, that means they are not meeting together, just produced only, apparently. So, what type of image is this? Which image is this? Real image. And which image is this? Virtual image. Just check whether the image is formed by actual intersection of refracted rays or reflected rays or not. If so, that is real image, otherwise virtual image. You sit away this side so that Purnima, she can see only your earlobe, become taller one. Real image and virtual image, so here are some differences. How many differences are given? 5. What is the first one? It is formed at the point where the refracted rays meet. They meet. Here, it formed at the point where refracted rays appear to meet. We have to produce and they meet. So here, I'll tell you, they are meeting here directly, but here appear to meet. Point number 3, always inverted. It is always inverted. See, down or not? Inverted means, suppose my position is like this, right? And in inverted position, head will be down, leg will be up. In South Indian movies, many more people, they are inverted, no? The gundas or hero, whatever they do, latka ke, not up to down, down to up. Legs are tied up and head down. Right? That is real image. Now, what type of this? Erect. So two differences we have done or not, right? Okay. So rest of others we will continue in our next period. Understood? Everybody take out your book, read once again and start making your notes.